It is not advisable to connect an aluminum wire ground and a copper ground to the same junction box directly. Aluminum and copper are dissimilar metals possessing distinct properties. A direct connection can lead to an unstable electrical connection and introduce a potential safety hazard. The differing metals may react, fostering corrosion which weakens or breaks the connection over time. This deterioration elevates the risk of electrical fires and electrical shocks. The recommended method for joining aluminum and copper wires for grounding purposes involves utilizing a specialized adapter or connector. Employ a splicing device that is explicitly engineered and certified for use in connecting aluminum and copper wires. These devices are designed to provide a secure and electrically sound connection. Install a pigtail, which is a short segment of bare copper wire, to the aluminum wire. Then join the pigtail to the copper ground wire by means of a splicing device. Make sure to insulate all connections with electrical tape. Always prioritize safety and seek guidance from a licensed electrician when undertaking any electrical wiring tasks. Ensure the electrical panel is de-energized turned off prior to commencing any work. Wear appropriate safety gear, which should include gloves and safety glasses. Thoroughly inspect all wires and connections for indications of damage or corrosion before making any connections. To elaborate further on the reasons why direct connection of aluminum and copper wires is discouraged, one must understand the electrochemical properties of these metals. Aluminum is more electrochemically active than copper, meaning it has a greater tendency to lose electrons in a chemical reaction. When these two metals are in direct contact, especially in the presence of moisture, a galvanic reaction occurs. This reaction causes the aluminum to corrode preferentially, as it acts as the anode in the electrochemical cell, while copper acts as the cathode. The corrosion process forms aluminum oxide, which is non-conductive and increases the resistance at the connection point. This increased resistance generates heat, further accelerating the corrosion process and potentially leading to a thermal runaway situation. In addition to the galvanic corrosion issue, aluminum and copper also have different coefficients of thermal expansion. This means that they expand and contract at different rates with changes in temperature. When a connection between aluminum and copper wires is subjected to temperature variations, the differential expansion and contraction can cause the connection to loosen over time. A loose connection increases resistance, leading to more heat generation and potentially resulting in arcing and electrical fires. The National Electrical Code, or NEC, provides guidelines and requirements for making safe and reliable electrical connections. The NEC mandates the use of listed and labeled connectors specifically designed for connecting to similar metals like aluminum and copper. These connectors are typically filled with a joint compound, such as an oxide-inhibiting compound, which prevents oxidation and corrosion at the connection point. The use of these specialized connectors ensures that the connection remains stable and conductive over time, minimizing the risk of electrical hazards. When selecting a splicing device for connecting aluminum and copper wires, it is crucial to choose one that is UL listed. AL, or Underwriters Laboratories, is an independent organization that tests and certifies products for safety. A UL-listed connector has been tested and found to meet specific safety standards, providing assurance that it is suitable for its intended purpose. Look for the UL mark on the connector packaging or on the connector itself to verify that it has been certified. Furthermore, it is important to follow the manufacturer's instructions when installing a splicing device. The instructions will provide guidance on the proper stripping length, tightening torque, and other critical steps necessary to ensure a secure and reliable connection. Failure to follow the manufacturer's instructions can compromise the integrity of the connection and increase the risk of electrical problems. The grounding pigtail method involves attaching a short length of bare copper wire to the aluminum wire using a suitable connector. The copper pigtail then serves as the interface between the aluminum wire and the copper ground wire. This method helps to minimize the direct contact between the aluminum and copper wires, reducing the potential for galvanic corrosion. When using the grounding pigtail method, it is essential to ensure that the connection between the aluminum wire and the copper pigtail is properly insulated. Electrical tape should be used to wrap the connection securely, preventing moisture and contaminants from entering the connection point. The insulation also provides protection against accidental contact with live electrical components. In addition to using appropriate connectors and methods, it is also important to consider the size and ampacity of the wires being connected. The wires should be sized according to the load they are intended to carry, and the connectors should be rated for the appropriate wire size and ampacity. Using undersized wires or connectors can lead to overheating and electrical failures. Always consult the NEC and local electrical codes for guidance on wire sizing and ampacity requirements. Regular inspection and maintenance of electrical connections are also crucial for ensuring long-term safety and reliability. Periodically check the connections for signs of corrosion, looseness, or damage. If any problems are detected, the connections should be repaired or replaced immediately. It is also a good practice to tighten the screws on electrical connections periodically, as they can loosen over time due to vibration and thermal cycling. When working with electrical wiring, it is essential to prioritize safety above all else. Always turn off the power at the circuit breaker or fuse box before starting any work. Use appropriate personal protective equipment, such as gloves and safety glasses, to protect yourself from electrical shock and other hazards. If you are not comfortable working with electrical wiring, it is always best to hire a qualified electrician to do the job. Firstly, ensure the power is off. Secondly, verify it is off with a multimeter. Thirdly, use proper tools. Fourthly, never work alone. Fifthly, always double-check your work. Sixthly, know your limits. Seventhly, consult with a qualified electrician. Eighthly, follow all applicable codes and regulations. Ninthly, test your work. Tenthly, label your circuits. The importance of adhering to electrical codes and regulations cannot be overstated. Electrical codes are developed by experts in the field and are designed to ensure the safety of people and property. By following these codes, you can minimize the risk of electrical hazards and create a safe electrical system. Local electrical inspectors are responsible for enforcing electrical codes and ensuring that electrical work is performed correctly. They can provide valuable guidance and assistance in ensuring that your electrical system meets all applicable requirements. When in doubt, always consult with a licensed electrician. A licensed electrician has the knowledge, skills, and experience necessary to perform electrical work safely and correctly. They can help you with everything from troubleshooting electrical problems to designing and installing new electrical systems. Hiring a licensed electrician is an investment in your safety and the safety of your property. Furthermore, always remember that electricity can be dangerous if not handled properly. Never take shortcuts or try to do electrical work that you are not qualified to do. If you are unsure about something, always seek professional help. By following these safety precautions, you can protect yourself and others from the hazards of electricity.